Okay, so how do we work a problem if they actually ask us for an X value instead of a percentage or a proportion or something like that? For example, this police academy problem. To qualify for police academy, candidates must score in the top 10% on a general ability test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Assume that the tests are normally distributed. Okay, so we know it's normal. But what are they asking us to do? Find the lowest possible score to qualify. So I need a score, and a score in this case is an X value. They tell us that the mean is 200, so that's important. Standard deviation is 20. And we know that the candidate must score in the top 10%. Okay, if it's the top 10%, that should be on the right side of the graph. So what we want to start by doing is going ahead and drawing our distribution. So we know it's on the top 10%. So the area to the right of that value, whatever that X value is, has got to be 10%. So if the area to the right of that is 10%, what is the area to the left of it? Well, it's 90% or 0.9. Now, why is that important? Well, if you remember our table that we're working with only tells us the left side areas. It only tells you from on this side of your Z value. So we need this side so that we're able to calculate this value here, okay? So what we want to do is go to that table, and we want to look at that table. We're going to look in the inside for the closest value we can find to 0.9000 or 0.9. All right, now we have to look in the middle of the table because if you remember, this top and side values here, those are both Z-scores. So the idea that we're going to do is we're going to find the area, and we'll convert it to or find the Z, and then from the Z we'll convert it to an X value. So it's essentially working the entire problem that we were doing prior backwards. So if we look at our table, you can see the closest value we can get here is 0.8997. Okay, so that's the absolute closest that we can get to 0.9. So now we're going to read our Z-score. That tells us that our Z-score is 1.28. Okay, so now that I have that Z-score, what I want to do is go ahead and convert that to an X value. So you know your Z formula. Your Z formula is X minus the mean over the standard deviation. So now what we can do here is convert this using algebra, or we can use our solve function on our calculator and actually plug in the values. Because I know the Z, it's 1.28. I know that that X is what I'm looking for. My mean was 200. And that standard deviation was 20. So now I got to perform the final step, which is finding that X. So we're going to solve it for X. And you can see we did that. And we get 225.60. Now this is a test score, so we are going to go ahead and round that up to 226. So this is our conclusion here. The cutoff, the lowest possible score to qualify, is 226. So like I said before, it's basically working that problem backwards. So here are your steps. Basically, the idea is you want to find the proportion in the body of the table. That's the middle of the table, okay? Then you're going to read the Z once you found that number, and then you convert that Z to an X value. Okay, let's try one more. For a medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. Okay, so middle 60%, that's what I'm looking for. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that would qualify people to participate. Okay, we're going to go ahead and assume that this is normal. Ideally, it would state that it was normal for us. We're going to go ahead and just make that assumption in this case. Normally, like I said, we wouldn't do that. But it says find the lower and upper readings. Okay, so we know we're going to have two readings. We're going to have an upper reading and a lower reading. Now, this middle 60%, we know that that middle 60% obviously is in the middle. So it's going to be in the middle of our curve. So it's going to be centered around the mean. So that's going to put 30% on either side of that mean. So let's go ahead and draw that out. So it should look like this. Okay, so you see it's in the middle, and we got that 30% on either side. Now, if 60% is in the middle, that leaves 40% for either side. So if we split that in half, that's 20% on either side. Here again, why is that important? Because remember, we're going to find those left side areas. It's not a big deal. Well, it actually is. We're finding this one, but it's a little easier because we know that this is 30 plus the whole distance across, which is 50%. So we know that that entire area there is 80. So that's going to be the value I look up. And then when I'm looking up this one over here, this x2, we know we're only looking up that left side. So let's go ahead and do that. So we know that this entire area is 80%. So we're going to go in the middle of that table and look for the closest value we can come to of 0.8. And that's 0.84, so approximately about 0.84. All right, so then so we've got this value here as 0.84. Now, we know that this graph is symmetric, and we know that it's 30% away from the mean here, so this other side should also be 30%. So with that being said, that means that this value here should be the same value as this one, but just on the negative side. So we know it's negative 0.84. But we can also look that up in our table. If we look our table, we know that this is 20% right here. So if we look up the closest thing that you can find to 0.2000 will be, and if you look it up, it is negative 0.84. So we have our two values. So what we want to do is go ahead and convert them to x values. So remember our formula is z is equal to x minus the mean over the standard deviation. So with a little bit of algebra, we get that upper score, this one, 0.84, is 126.7, and the lower score is 113.28. So we know in order to be a part of this study that they're doing, that the middle 60% of the readings are between 113 and 124. So you're going to have a blood pressure between 113 and 127 to be a part of this. So between 113 and 127.